Welcome everyone to my presentation. Today I'll be sharing what I find fascinating about Ohm's law with some real-world applications and some innovative ideas that take Ohm's law beyond the basics. So Ohm's law is a fundamental relationship in physics that is defined by the equation V equals IR, which explains how these variables interact in electrical circuits, which we have already learned in lecture, but I wanted to include this photograph because I find it pretty funny how this represents the relationship between the three. This is a formula triangle for Ohm's law that was extremely helpful for me for visualizing the relationship between the three different components. Using the triangle, we can easily build any of our equations for voltage, current, or resistance. This should look familiar as we conducted an experiment in our virtual lab with a variety of circuits, but I want to explain what's going on here before I move on to the household examples. So if we take a look at example one here on the left, we can see a fuse in series with a 10 ohm resistor and a 50-volt battery. The electron flow through the circuit is steady since the maximum current the fuse can carry is 5 amps. And in example two, we have the exact same setup, but the voltage is increased by 1/10 of a volt, which overpowers the fuse and blows it out, completely interrupting current flow. This is crucial to understand when it comes to designing real-life applications. And let's take a look at some of those real-life applications. Okay, so for household examples, I got a hairdryer, a circuit breaker, and a stovetop. For the hair dryer, it uses a specific coil to heat with the hair dryer uses a heating coil with a specific resistance. And when the hair dryer is switched on, the voltage applied causes a current to flow through the coil, generating heat. There's a fan, if you can see right behind the top left, that behind that picture, there's a fan behind the coil. And when resistance goes through onto the coil, heat is applied, and the fan blows the heat out, which is what's drying your hair. For my second example, a circuit breaker, which protects a circuit by using Ohm's law to detect when too much current is flowing. If a fault or overload occurs, resistance in the circuit increases or the current exceeds the safe limit, causing the breaker to trip. An increase in current under a constant voltage will cause the circuit to exceed the designated resistance, activating the breaker to interrupt the flow and prevent damage. This is why you have to flip it back on or turn it all off sometimes. Lastly, an electric powered stove works by using electrical resistance to generate heat. It's similar to the hair dryer, but the coils require more resistance to get hotter to cook your food. The higher the resistance, the more heat generated, allowing the stove to heat up and cook the food. One unique example that came to mind was the electric chair, and this scene from one of my favorite shows, Prison Break. So for the electric chair to work, it starts by applying a high voltage to the body, and I found around 2000 volts to overcome its natural resistance and ensure that a large current flows through it. Using Ohm's law, the high voltage ensures that sufficient current flows, even if the body's resistance is significant. The voltage is maintained for several seconds to sustain the current, which disrupts electrical signals to the heart and the brain, leading to cardiac arrest and brain death. The resistance of the body plays a crucial role in the efficiency of the electric chair. And so when I was watching the show a couple years ago, Prison Break, they placed a wet sponge on the main character, Lincoln Burrows' head. And I wasn't quite sure why, so I did some research and I found that the human body can have anywhere from 1,000 to 100,000 volts or 100,000 ohms of resistance. So depending on different conditions like dry skin and point of contact, wetting the skin can lower the body's resistance significantly. And without proper contact or preparation, the electric chair would be insufficient, or the current would be insufficient, or it wouldn't be practical. Or wouldn't choosing the electric chair as an example actually led me down a fascinating rabbit hole about the resistance within the human body. So, while researching about the resistance of the human body, I learned that different parts of the body have different conductivity. This is a property of the tissue that is commonly used for medical imaging. One example is electrical impedance tomography, also known as EIT. And simply put, here in the top left, you can see EIT. EIT is a medical imaging that uses electricity to create pictures of what's inside the body. It's like using an X-ray or ultrasound, but instead of using light or sound waves, it uses small electrical currents. The human body also generates current in the brain, which doctors regularly use brain electrical source analysis like EEG to figure out where the brain electrical signals are coming from. For example, this helps find the part of the brain causing seizures in people with epilepsy. And I find it incredible that all these different techniques utilize Ohm's law to measure how electricity flows through the body. And different tissues like muscle, fat, or bone actually have different resistances to electricity. And by sending small electrical currents into the body and measuring the voltage, doctors can calculate resistance and generate images of what's happening inside, whether it's the brain, heart, or other tissues. To segue into my own career path, I wanted to add some dental field applications. I was interested in researching and finding out if this applied to my field at all. This tool over here on the left is a scaler, and it is commonly used by dentists to scrape off plaque from the teeth. Now, this is an electric scaler. So the electric scalers convert energy into vibrations to clean teeth. To achieve the correct current needed for the scaler to vibrate at optimal speed, the voltage must be carefully controlled. If the voltage is too low, the scaler might not vibrate effectively, reducing its cleaning efficiency. And if it's too high, it could overheat, causing discomfort to the patient or to the dentist. Another tool that comes to mind is the curing light. And curing lights emit specific wavelengths to harden dental materials. The light bulb for LED or the light bulb or LED has a specific resistance. Maintaining the correct circuit conditions using Ohm's law, it makes sure that the curing process is effective and prevents overheating materials. One example when they use the curing light is when they would polish the tooth, they would put either they would put a bracket on top, where they would put glue with a bracket, and then they'd cure it in spot to hold the bracket down, or for a filling, after they shape the filling to the tooth to make everything to cover up the cavity after they clean it, they would harden it with the curing light. Now, and I'm glad I could connect my topic to the medical field, which aligns with my career goals. And I hope my presentation has sparked your curiosity and emphasized the importance of Ohm's law, showing how fundamental concepts can lead the way for ideas that go above and beyond. Thank you for watching.